We have the following numbers over here: 280, 256, 1000, 820, and we want to write this as a product of prime factors. We give the result in index form. So what we have to do, there is an algorithmic approach in order to write these numbers in index form as a product of prime factors. So let's start from 280. In the first column here we put the number. In the second column we start and divide by the first prime number. Can we divide by 2? Yes, this gives us 140. 280 divided by 2, 140. Then we divide by the prime number 2 again, because we get a perfect division. So this is 70. 70 we continue to divide by 2. We get 35. 7 divided by 2 gives 35. Now we go to the next prime number, which is 3. But if we divide by 3, we don't have a perfect division because we have a remainder. And then the next step is to divide by 5, which is the next prime number after 3. 35 divided by 5 gives me 7. We go to the next prime number. 7 divided by 7 gives me 1. And that's it. When I end up here having 1, all I need to do is multiply these numbers. So 280 equals 2 to the third power times 5 times 7. Let's see, this gives me 8. 8 times 5 gives me 40 times 7, 280. This is my result here. So we write 280 as a product of prime numbers in index form. So index here is 3, 1, and 1. 256. We use the same approach. Divide by 2 is 128. We divide by 2 again is 64. Divide by 2 is 32. Divide by 2, this is 16. 16 divided by 2, this is 8. 8 divided by 2 gives me 4. 4 divided by 2 gives me 2. 2 divided by 2 gives me 1. 256 equals, we have 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 8. We can verify, so this is 2 times 2, 4, times 2, 8, 16, 32, 64, 128, 156. Let's go to the next one, which is 1000. We divide by 2. This gives me 500. Divide by 2, 250. Divide by 2, 125. Then we have to divide by 5, which is 25. 25 divided by 5 is 5. 5 divided by 5 is 1. So 1000 equals 2 to the third power times 5 to the third power. Indeed, 2 to the third power, if we can write this 2 times 5 to the third power, so it's 10 to the third power is 1000. So this is correct. Let's go to the last case, which is 820. So we divide by the first prime number, which is 2. So is 410. We divide by 2. 205. We divide by 5. and this gives me 41. 41 divided by 41 gives me 1. 820 equals 2 to the second power times 5 to the first power times 41. So this is 4 times 520. 20 times 41 is 820. In all these cases, let's go back to the first one. In the second column, we start divide by first prime number, which is 2. And then we continue to divide by 2 and get a perfect division. If the division leaves a remainder, we go to the next prime number, 3, 5, 7, etc. So we have only prime numbers here in increasing order. And this is the index form. So we have 280, a unique representation of a product of prime numbers in some raised into some power. So the 280 can be uniquely represented by this product of prime factors in index form. And the same applies for the rest of the three numbers, 256,000 and 820.